Hi, my name is Batu Ustegül. I'm a second year computer science student at Bilkent University. I'm here to present my Physics 101 project. My project's name is Calculating the Coefficient of Friction on Circular Motion. When calculated, we can see that coefficient of static friction does not depend on the mass of objects. It depends on the velocity of spinning, the radius of spinning, and the gravitational acceleration. In here, we proved that the coefficient of static friction does not depend on mass. It depends on velocity, gravitational acceleration, and the radius. To calculate with the velocity of spinning, we need the velocity to be constant. To provide this, we need a frictionless environment between the surface and the surface it's spinning on. To demonstrate my project, I chose an air hockey table to provide frictionless environment, a circular surface to spin, and a light element to calculate the friction force. I marked my circular surface with 1 cm intervals to access the radius. Now I have a frictionless environment, the radius of spinning, and the gravitational acceleration. The last thing I need is to calculate the velocity. To calculate the coefficient of static friction, I spin my object more than 50 times. I calculated each spinning's period and velocity. I found a video where the object is not throwing itself out and I spin it with the maximum velocity, and the video that the object is throwing itself out and I spin it with the minimum velocity. Later on, I calculated the periods of these two videos more accurately. In here, I am deriving the formula to calculate the coefficient of static friction with only the radius, gravitational acceleration, and the period. These are the details of my experimental data. My radius is 1 cm. The gravitational acceleration value is 9.81. The fastest stable period that I have calculated is 0.92 seconds, and the slowest slipping period that I have calculated is 0.89 seconds. For the fastest stable spin, I have calculated that for 0.92 seconds, my coefficient of static friction is 0.0476. For the slowest slipping spin, I have calculated that for 0.89 seconds, my coefficient of static friction is 0.0509. In conclusion, this experiment successfully demonstrated the relationship between circular motion and static friction. By deriving the formula for coefficient of static friction, we proved that the coefficient of friction depends on the radius and period of rotation, but crucially is independent of the object's mass. Using a radius of 1 cm, we identified the critical limit of stability. The object held its path at a period of 0.92 seconds, but slipped at 0.89 seconds. Based on these measurements, we calculated the coefficient of static friction to be between 0.048 and 0.051. This result confirms that even with a very small radius and low friction, the laws of physics reliably predict exactly when an object will spin out of its circular path.